Alright guys, welcome to the Mid-Chapter 9 review, lessons 9.4 to 9.6. Make sure you have something to write with and paper. Because the biggest lie I can tell myself is that I don't need to write that down. I'll remember it. So write it down. Thank you. Alright, so again a review, lesson 9.4. Perimeter means you're finding the distance around the outside, kind of like a fence for a backyard. You're going to add up all the sides. If there are 4 sides, add all 4 sides. The area is the amount that it takes to cover a space. So in the picture here, kind of like the green grass that's drawn to cover the rectangle. Okay, on the quick check from lesson 9.4, some of you had trouble putting your answer into words and describing the change of the perimeter and the area and justifying your answer. So look at some things I've already put on the page. I underlined that the perimeter, or excuse me, each side length of the parallelogram shown below is multiplied by 10. So each side length is multiplied by 10. You are to describe the change in the perimeter. The change in the perimeter, the new perimeter, would be 10 times larger because the new side lengths are 10 times larger. Perimeter means you're adding up all the sides. Some of you, when you gave this answer, gave it to me as the area. Okay, remember again, perimeter means you're adding up all of the sides. So in the original figure of the parallelogram, the perimeter would be the side 14 plus 12 plus 14 plus 12, with a total perimeter of 52 centimeters. The new perimeter, because you are multiplying each side by 10, you would have a side that's now 140, 120, on a parallelogram. Opposite sides are the same. When you add that up, you get a total new perimeter, the new shape, of 520 centimeters. So you found the old perimeter, 52, you found the new perimeter, 520. Show that with the division, like you see here. And when you divide, you should come back to 10 because you multiplied by 10. So this is the answer to number 1 on the quick check. Moving along to question number 2 on the quick check. 2 regular pentagons highlighted that they are regular, meaning all sides are equal, all 5 sides of the pentagon. How many times greater is the area? Now, the effect on the area is different than the effect on the perimeter. Okay? So if the area is squared, then you have to square the change in size. So in moving from the small pentagon at 4 inches to the larger pentagon 16 inches, the change is that it's been enlarged 4 times. But the area is squared, so it would be 4 squared larger. 4 times 4 is 4 squared, 16. So the answer to number 2 is that the area is 16 times larger. Okay, you have to be able to justify, describe, explain your answer. Those will be the types of words you'll be asked on tests and quizzes. Okay, moving along to question number 3 on the self-check for lesson 9.4. This is a multiple choice test practice question. So you have 2 equilateral triangles, which I tried to draw a picture of both of these. One has a perimeter of 18 inches, so I have P equals 18 for the smaller triangle, and 36 meters. Okay, so by changing them, you see that you are multiplying by 2, meaning the perimeter is doubling. How many times greater is the area of the larger triangle? Well, again, you're doubling in size, okay? The perimeter is 2 times greater, but the area is 2 squared, 2 times 2, or 4 times larger. Okay? So you have to be able to describe the effect. Here's a page from your workbook demonstrating the key concept, changing dimensions, and the effect on perimeter. So I underlined, put an asterisk by the part mentioning if the dimensions of a polygon are multiplied by x, then the perimeter of the polygon also changes by x. In this example, figure A triangle to figure B triangle, the side dimensions are multiplied by 2. So the effect on the perimeter is the same. The perimeter is also doubled. Okay? If you were to triple the dimensions, then the perimeter would triple. Okay, and the other key concept from the page in the workbook, changing dimensions and the effect on area. Again, look at what's circled and underlined and highlighted here. If the dimensions of a polygon are multiplied by x, then the area of the polygon changes by x times x, or x squared. If you think about that, that's because area is squared. We talk about square units, a side times a side. Centimeters times centimeters, meters times meters. That's why the units are squared. So the effect on the area is also squared. Now moving into lesson 9.5. Polygons on a coordinate plane. So here's a picture of a coordinate plane, your x line or your x-axis and your y-axis. Okay, a reminder to you in yellow over here, you move the x point first, and you're either moving left or right depending on whether it's negative or positive. The second number that you move is the y-axis, so you will either be moving up or down, again, depending on whether it's a positive or negative effect. Okay, we're going to work through a question number 18 from homework, where you were told to graph each figure by plotting the points. Then classify it. Is it a triangle? Is it a rectangle? Whatever the shape is, then find the area. You should always be telling me the formula, substituting in the numbers, and solving it, showing calculations as necessary. I wanted to make sure to pick a problem where you had to graph some of the negative numbers, just to go over that as well. Now we're always going to start here in the middle, which is called the origin at 0, 0. I'm going to go ahead and erase that now and start. So point G would be -4, so you're going to go over 1, 2, 3, and -4, and then you're going to go up to +1. Okay, so I'm going to erase this here and show you that I go over to -4 and up to +1. It's hard to do the little point here, but this is point G. Alright, then again, back to the center, 0, 0. You're going to go across to the right, +4, and you are going to go up to 1. Sorry, having issues here. Trying to get the dot in the right space. Okay, so there's point H. Then we have point I. Again, we move over, in this case to the right, positive 3, but this time we're going to go down to a negative 3, which would be about right here. Excuse me. Let me fix this. Alrighty, had to fix that. So we're at 3 and negative 3. So 3 to the right and 3 down. And this is point I. Then the last one here is going to be point J. Negative 1 to the left and negative 3, we're going down. Okay, and there's the point J. Okay, so next we basically need to connect the dots. Straight line as much as possible. It's a little hard with the stylus to do that, but okay. And I would definitely say this is a trapezoid. Okay. It's a trapezoid. I have a formula for the area of a trapezoid. That formula you can write several different ways. This is the one we've been using in class. B1 plus B2, meaning base 1 and base 2, times the height, and then all of that divided by 2. All right, now, how do we know the side lengths? Well, it really doesn't matter whether you call this B1 or B2, but it is the base. Okay, they are both bases, and they are the lines that are parallel to each other. So the base 1, you would be able to count, and I'm going to switch colors here and show you that you can count the units here, how far you go over. So that would be 4 units. All right, for base 2, starting here, you would count all the way over from one vertex to the other. So you've got a total of 1, 2, 3, 4, 5, 6, 7, 8. So B2 equals 8. Now, we also need the height. And the height, if you remember, I'm going to change colors, but the height is coming down, straight down, making a 90-degree angle. So it's not the slant height, but we're talking about right here. And this is making a problem again. Let me see if I can get rid of it. Okay. We're talking about coming right down here, and it makes a 90-degree angle. It even looks like a little H, so we would say the height is 1, 2, 3, 4 units. Okay, so the height equals 4 units. Okay, this has gotten a little messy, so I'm going to put this on a piece of lined paper. Okay, so now I have the area formula for a trapezoid written here again. We found our base 1, base 2, and our height. So now I'm going to plug those in. This is the substitute part that I call. And one of the bases was 8, one was 4, and the height was 4. And we're going to take all of that and divide by 2. Now, there's some tricks along the way that we've learned, and I want to show you another color here. Some of you have picked up on the fact that there are some easy numbers on the top there. So I can go ahead and take care of 4 divided by 2 and make this a little bit simpler. So I'm going to go back to the orange and say, I'm going to do a simplification step and say 8 plus 4 in the parentheses is 12, but I'm also going to say that 4 divided by 2 is 2, so I'm left with the last step of saying 12 times 2 is 24, and I believe these were just square units. I don't think they told us they were centimeters or anything in particular, so we can leave that the area of the trapezoid on the graph is 24 square units. Okay, so another homework problem. This is number 8, and the question reads that the shape is a rectangle. It has a perimeter of 20 units. The coordinates of 3 vertices listed in blue are already plotted with the blue dots on the graph. Part A is find the coordinate of the missing vertex. Since you know it's a rectangle and you know the properties of a rectangle, you know that the missing vertex must be here, starting at 0, 0, and then you need to walk all the way up to 4. So it is 0, 4, and that is, yeah, just not working so great. But the missing coordinate would be 0 for your x and 4 for your y. And then you can see that that would make a rectangle if you were to put that together and your lines were straight, unlike mine. Okay, I decided to delete a problem that was way too involved for what you're going to have on the test, so you may need to delete part of what was said earlier. Focusing on lesson 9.6, area of composite figures, reminding yourself the work you must show here, drawing the shapes, finding the missing dimensions. Please write the correct area formula. You must substitute the numbers, show your calculations, add the area of all the individual shapes after you have broken them down, and since it's area, use proper square units. Okay, so we're going to focus on this problem 14. Looking at the diagram that is circled in red, this is a living room. The wall needs to be painted. Your job is to find the total area to be painted. Okay, that would be our strategy of the whole minus the part. That would leave us the painted part of the wall. So in this case, the area of the whole entire rectangular wall would be the whole, minus the area of the door and the window, since those are not painted. Okay, so looking at the area of the rectangle of the larger room, redrawing that shape, you have a side that is 15 and you have a side that is 12, and you would need to multiply and find the area of that large rectangle. You would also need to find the area of the door, which is 8 feet times 3 feet, and the area of the window, which is 4 feet by 3 feet. So I'm going to go to another page with lined paper and pause a minute. Okay, back to the lined paper. What's written in red? We have the area of the whole entire wall. Area equals base times height for the rectangle, which is 15 times 12. If you take time to work that out, 15 times 12 gives you an area of 180 for the whole. Okay, changing colors. The area of the door, this shape, colored brown, is an 8 by 3, base times height, so the area of the door is 24 units. The area of the window, you can see the work here, 4 times 3, that would be 12. Okay, so here is a part, the door, here is a part, the window. Okay, so you could say 24 plus 12, changing the color here. The parts, 24 plus 12 equal 36. So the whole entire wall, 180, minus the parts that are not painted, okay, 180 minus 36, so you would subtract. Some of you need a reminder that that would go to 17, and 17 minus 3 would be 144. And these are units that are listed in feet. So the total amount of area that needs to be painted would be 144 square feet. Now I'm not going to go further in the explanation about figuring out the cost, although that is a good part of the question. I just wanted to recap how to do the composite figures. So good luck on your test tomorrow. Thanks, Miss Gregory.